So when it comes to exponents, I picked these problems to really practice the rules when you have positive exponents, negative exponents, zero exponents, and to see what the exponent applies to. Because once we start working with exponents and simplifying these expressions, people start getting confused on what to do with the exponent. And so I just want to start with these examples just to kind of break it down and explain what's going on here. So I'm going to start on the left. I've got A through F here. So for A, we have -7 squared. So when you have a negative squared, if that negative is in parentheses, that's going to include the negative. So that's a negative times a negative. So we're going to get a positive answer. So this will give us a positive 49 because -7 times -7 is positive 49. Now B, that negative is not in parentheses, so it is not included in the square. That square is only on the 7. So that's saying 7 times 7, which is 49, and then we have a negative in front. So this would give us a -49. And this is really important. A and B are really important because people often mess that up. They'll either write what you see in B, but mean A, where you don't write it properly, you miss your parentheses, or they want to do A, but they enter it into the calculator as B, which then gives you the wrong answer. So it's really important to write down exactly what you are intending to do and to also enter it in your calculator the same way. So that way you don't either have your work not matching your answer or you don't have the wrong answer on your calculator. And so that's also, you want to understand or know whether your answer is supposed to be positive or negative to help you find those mistakes as well. Now, C and D are where we now are throwing in a negative exponent. So a negative exponent means you take the reciprocal and then the exponent becomes positive. And this is just one of our rules. On my YouTube channel, I have a video that explains why this rule exists. So if you are one of those that likes to know the why, you can search my YouTube video for exponential expressions and it will come up. But I'm going to just go over the rules and how to apply the rules here. So a negative exponent, to make it positive, you take the reciprocal. Now in C, that negative exponent, that -2 is only on the 7. So that we're taking the reciprocal of the 7. That negative is not part of it. So usually we just end up with that negative in front. And then we're going to have the reciprocal of 7, which is 1/7, and then the exponent becomes positive. I'm going to actually see if I can make get thinner here. That's much better. So that will give us a -1/7 squared, because to make that exponent positive, we have to take the 7 and turn it 1/7, and then that exponent is still attached to that 7. And then we take 7 and we square it, so this is going to give us -1/49. Now this is different from D because the negative is now in the parentheses. So in D, we're taking the reciprocal and we're taking the reciprocal of the -7 part. So now you have that -7 in parentheses as squared, because now when you take that reciprocal, the exponent becomes positive. And then we saw in part A, -7 squared is 49. So this gives us a positive 1/49. So where the parentheses are really matters for your answer. Now, E and F, we're again looking at -7. with parentheses and without parentheses, but now our exponent is 3. So that's an odd number, and when you have an odd number exponent, that means you're going to be multiplying an odd number of times. So for example, we've got e here, which is -7 to the third. It's going to be -7 times -7 times -7. And so that gives us 3 negatives. 2 of them cancel out, and so our final answer is negative. So the parentheses and the -3 cubed is going to give us a negative answer back, and then 7 cubed, which I need to grab my calculator for, 343. Now in F, we're cubing 7, which is 343, and then we have a negative in front, and so we end up with the same answer. So the lesson here is that with odd numbers, odd number exponents, whether you have parentheses around a negative or not, it doesn't matter because you're still going to get a negative answer. But for even exponents, when you square or have an even exponent on something that's negative, the parentheses matter because that determines whether you're going to have a positive answer or a negative answer. So, Raven, you were going in and out. I don't know how much you, I don't know if there's connection issues on your end because Danny left as well. Are you able to hear me right now?
Yeah, I was having some connection issues, but I think the part where I was having the trouble was if it has parentheses, whether it was negative or positive.
Okay. And so that's like parts A and B here then, or that difference. Yeah. And so that's really important to understand whether the negative is included or not, and that's all if is there like parentheses around it. So like on the right here, I've got A, B, C, and D. So this is the rule with a 0 exponent. Any exponent of 0 makes your thing 1, basically. So anything in parentheses, it doesn't matter what is in parentheses. If the outside exponent is 0, it's going to be 1. So -2/3 is going to give me 1 because the whole -2/3 is in parentheses. So on B here, we have a negative and then 2 to the 0 over 3. That 0 is only attached to the 2 because there's no parentheses or anything else. So that's the only part that becomes a 1. So this would become a -1 over 3. And in C, we have a 0 on our variable. That's the only part that has the 0 attached to it because there's no parentheses. So that becomes 1. And this would be -2/3 because it would be -2/3 times 1. And then D, everything in parentheses, is that 0 is attached to everything on parentheses there. So that whole thing will become 1. So where your exponent is located, whether there are parentheses or not, huge difference on what you do with your, how you simplify it. It really makes a big difference. So I think I'm going to, let's do A here on the right, because this will be a good one. So with the negative exponent, you take the reciprocal to make it positive, the exponent positive. Here, because our negative exponent is the denominator, when we take the reciprocal, we no longer get a fraction. And so that will give us q to the second power. So negative exponents basically flip-flop a problem or whatever you have a negative exponent on for the top of a fraction of the bottom and vice versa. It just flips it from the top to the bottom, and it just depends on whether your negative's in the denominator or the numerator on where it flip-flops. And when it does that flip-flop, the negative disappears and becomes positive. And if you had a positive exponent and you wanted to flip-flop it to the other side, then you would make it negative. So you'd make the exponent negative. So just basically going from top to bottom, it just changes the sign of the exponent in order to do that. I think I'm going to do some where we're following these rules of exponents and trying to figure out what things get attached to what and simplifying all of that kind of stuff. So, okay. So here's an example. P squared times Q over P to the 5th Q to the -1. So here we have a fraction and we have variables on the top and the bottom. And when we simplify things that are in a fraction, you subtract the exponents top minus bottom, and you want to match your variables together. So we'd be simplifying the p's, and then we'd be simplifying the q's. If the variable doesn't have an exponent on it, you can make it have an exponent of 1. So like that q on top, I don't have an exponent, so I can put a 1 there. And then it has an exponent of 1. And so when we simplify here, we subtract top minus bottom. So for the p, it's 2 minus 5. So I'm actually going to write that out so you can see that. That's what we have for our exponent. And then q, it would be 1 minus -1. So our exponent on p, 2 minus 5, is -3. And then the exponent on q, 1 minus -1, that's the same as doing 1 plus 1, so that becomes 2. Now, our final answer, we don't like to leave negative exponents in the denominator. Basically, leave anything with a negative exponent, whether it's on the top of a fraction or a bottom. We don't want to have negative exponents. So we want to take this p to the -3 and rewrite it so that way it has a positive exponent. And we do that by taking the reciprocal. What that does here is we don't have a fraction. We're basically going to create a fraction where that p is going to be in the denominator. I wish I could just add this thin pen as a favorite here. So q squared, if it's not in a fraction, it's going to be on the top of a fraction if you create a fraction. And then that p is now going to have a positive exponent, but now it's in the denominator because we had to flip-flop it because of that negative exponent. And then we have two different variables here, so we can't simplify them, and we don't have any negative exponents, so there's nothing else to do there with that. So your first step is to basically do your subtraction of exponents, and then any negative exponents, you have to basically flip-flop those things with negative exponents to get your final answer. Here's another example. Very similar, but different numbers and variables. So we have m to the -1 n cubed. Should make that look like a 3 better. And then m to the 4th and n to the -2. So again, the m's are going to be grouped together. The n's are going to be grouped together. and then we're subtracting exponents. So for m, it's the top minus the bottom, so that's going to be -1 minus 4. And then n, it's 3 minus -2. And so when we simplify, -1 minus 4, we get -5 on our m. And then on the n, 3 minus -2 is the same as 3 plus 2, so that gives us a +5. And then that negative exponent, we want to flip-flop it to get a positive exponent. The n to the 5th is not changed, but now the m is going to be the denominator in order to make the exponent 5 instead of -5. Are there any questions? Okay, I'm going to throw in some numbers here, so that way it's more than just variables. -48a b to the 10th over 32 a to the 4th b cubed. So we're going to group things together as we simplify. So we're going to treat the number like it's a fraction to reduce. And then we're going to be working with our variables here. So we'll be doing the a and then the b. So you'll treat each of those separately to get your answer. So the -48 over 32, that is a fraction that we want to reduce. And I can divide both of those by 8. 48 can divide by 8, and 32 can divide by 8. So 48 divided by 8 is 6, so this is going to be a -6. 32 divided by 8 is 4. So I get -6 over 4, which actually I'm going to be able to reduce further. So I can do that in another step. Then I want to simplify my a variables here. And my a on the top does not have an exponent, so I want to write an exponent of 1 so that I can do my subtraction of exponents here. So it's always the top minus the bottom. So that's going to be a, and then it's going to be 1 minus 4. And then b is going to be 10 minus 3. So I'm going to reduce my fraction again, my -6/4. I can divide those both by 2, which gives me -3/2. And then I get a, and then 1 minus 4 is -3. And b, 10 minus 3 is 7. So I've got -3/2, a to the -3, b to the 7. Now, when we write our answers here, we don't want to have that negative exponent. So I'm going to have to rewrite this a to the -3. And we also want to try to combine these all in the same fraction. So, oops, I want my thin one. I'm going to have a -3, and then that b to the 7th, because it has that positive exponent, so it's going to be on the top of our fraction here. And then I have a denominator of 2, and then that a to the -3. To get rid of that negative exponent, we're going to take the reciprocal. So now it's going to be in the bottom of the fraction. So I'm going to stick it on the bottom next to the 2, and now the exponent is positive. So we have a to the 3rd. And then you just double check to make sure your numbers are reduced all the way, that you don't have any more negatives in the exponent. And that would be your final answer here. So you kind of treat your numbers differently from your variables, and you simplify each of those, and then you try to recombine them into a single fraction to get your final answer. Now there's another, that's sort of talking about like the dividing with the exponents here. Let's do a different rule. We have negative 3x to the negative 4th, y to the 5th, z squared, and then the exponent is negative 4. So I've got lots of things going on here, and they're all within parentheses, and then we have that negative 4 on the outside. So when we want to simplify something like this, we have to use what is called the power of a product rule, where you're basically distributing your exponent. So this outside exponent gets applied to each thing inside the parentheses. And so I like to write these with a parenthesis around it just to make it very clear, especially when you have that negative. So that negative 3 is going to have an exponent of negative 4. Then we have x to the negative 4th, which has an exponent of negative 4, and that second negative 4 is from the outside negative 4. Then we have y to the 5th, which has the exponent of negative 4. And then z squared has an exponent of negative 4. So that negative 4 on the outside gets applied to everything on the inside. And then we're going to simplify each of these in their own groups. So negative 3 to the negative 4. When we have a number and then we have a negative exponent, that means we need to rewrite it to have a positive exponent. So we're going to be taking the reciprocal here. I'm going to just do this one underneath because this is getting long. So instead of negative 3 on the top, it's now going to be 1 over that negative 3, and then the exponent becomes positive when we take that reciprocal. Now moving on to the variables, when you have an exponent and then another exponent, that's the power of a power rule, and you multiply those exponents together. So we have x to the negative 4 times negative 4, and so that's going to give us x to the positive 16. And we do the same thing with y. We have 5 times negative 4. So that's going to be negative 20. And then on the z, we have 2 times negative 4. So that's negative 8. So we're multiplying our exponents, unlike the previous problem where we were subtracting because they're in a fraction. If you have an exponent on top of another exponent, you multiply. And if you want, you can take an extra step to write those out. So instead of writing the actual answers, I can write the multiplication if you want to make it very clear that you're multiplying those together. And so we would have 1 over, we have our negative 3 to the 4th power, which you can do that on a calculator. It's a negative with an even exponent, so that's going to give us a positive answer out. And that gives us 81. And then I write those multiplications. So once you've simplified your exponents here, then anything that has a negative exponent, we need to flip-flop, basically. So the y to the negative 20 needs to flip-flop, and the z to the negative 8. And those are currently not in fractions, so those become part of fractions being in the denominator. And so those are going to be put with the 81 in the denominator. So I'm going to just go to the right here. Now on the top of our fraction, we have a 1 from the 1 over 81. And then we have this x to the 16th that we're not doing anything with. So that's going to be on top of our fraction, and we usually don't write the 1 if we already have something else on there. So we're just going to have x to the 16 on top. And then in the denominator, I have 81. Then our y to the negative 20 becomes a y to the positive 20 when it moves to the denominator. And then z to the negative 8 becomes z to the positive 8 when that moves to the denominator. And that's usually the last step that you do. So that gives us x to the 16 over 81, y to the 20th, z to the 8th. Here's another good problem. 4m to the negative 2n times negative m 6n to the negative 3. So here we don't have any exponents on our parentheses, but we have things multiplied together. And so you want to group things like we did with the division here. So I'm going to group my numbers together, and if there's a minus sign without a number, we consider that a negative 1, so those would be grouped. And then I'm going to be grouping my variables, my m's, and then my n's. So we can rearrange this to make it easier, because when you have a whole bunch of things multiplied together, the order that you multiply them doesn't matter. You can rearrange them. So I can write this as 4 times a negative 1 from that negative in the second set of parentheses. And then I can put my m's together, m to the negative 2 and m to the 6th. And I can put my n's together, n, which does not have an exponent, so I can add an exponent of 1 there, and then n to the negative 3. So when we're simplifying something like this, our numbers, you just multiply your numbers together. 4 times negative 1 is negative 4. On the variables, you add your variables. So when you're multiplying, or you add your exponents. When you're multiplying, the exponents add. When you're dividing, like in these problems, they subtract. So for m, we're going to be adding negative 2 plus 6. And for n, it's going to be 1 plus negative 3. So we simplify those. We have negative 4m, and then negative 2 plus 6 is 4, and then n, 1 plus negative 3 is negative 2. And now we have this negative exponent, and we want to make it a positive exponent for our final answer. So that's going to give us a fraction, because right now it's not in a fraction, so it's going to be in the denominator. And the negative 4 and the m to the 4th are not moving, so those become the top of the fraction. And then n squared is in the denominator, because the exponent now becomes positive. Are there any questions on any of these? Okay. I'm going to mix these up and do a multiplication and an exponent thing. P to the negative 2 q cubed times 2p q to the 4th. So when you have multiple things going on here, we've got our exponent on a set of parentheses, and then we have things multiplied together. You always do the exponent on parentheses first, because order of operations says exponents they happen before multiplication. So I need to distribute this exponent of 3 before I start doing anything else. So p to the negative 2 has an exponent of 3. And q, which doesn't have an exponent, so we'll give it an exponent of 1, has that exponent of 3. And then in the other set of parentheses, we don't really have anything to do, so that's just 2p q to the 4th. Now, simplifying your exponents, multiplication has to happen before addition, so I need to multiply my exponents when I have the exponents on top of each other. So I have to simplify the p here and the q here first. So that is multiplying, and I'm going to just show every step here by writing the multiplication, just to help you remember. And then I'm not doing anything on this 2p q to the 4th yet. So when I multiply on the p, negative 2 times 3 gives me negative 6. And on the q, I have 1 times 3, which is 3. And then I have this 2p q to the 4th. Now everything here is multiplied together. And so now we want to group things together like I did on the previous problems, where you put the numbers together, your variables together, and match them out. So I only have one number here, which is 2, so that's going to go in the front. Just one coefficient. Then I'm going to group the p's together. So one has an exponent of negative 6. And one of them doesn't have an exponent, so I'm going to just write a 1 there. And then I'm going to group the q's together. So I have an exponent of 3 and an exponent of 4. Now I'm going to simplify the p's and the q's. When they're multiplied, the exponents add. So I'm going to write that out, negative 6 plus 1. And on the q, we have 3 plus 4. So this gives us 2p, and then negative 6 plus 1 is negative 5. And then q, 3 plus 4 is 7. So now we have this negative exponent, so we have to do the flip-flop, where now that's going to be in the denominator. So we have 2 and q to the 7th on top, and then p to the, positive 5. Oh no. There. P to the positive 5 ends up in the denominator. So when we flip it, that negative exponent goes away, and we now have that positive exponent. Here's another good one. We can do these all day. There's so many variations of these. 5x squared over y to the third, and then 5x squared y. When you have an exponent on the outside of a fraction, and it's got a set of parentheses, it distributes just like on the previous problems, but it makes sure it goes to the top and the bottom. So on these two examples, or this one and then this other one, they were all multiplied together and it distributed everything. It's the same thing whether they're multiplied or divide. You distribute that exponent. So we're going to have x squared get an exponent of 3. And then that y, which doesn't have an exponent, so I'm going to write it as a 1, gets an exponent of 3. And then we have our 5x squared y. Now, when you have a fraction and then you have something that's not a fraction, it's usually helpful to write the thing not as a fraction so that you can make sure things get multiplied together correctly. So you can do that by just writing it over 1. Now, just like the previous problem, I need to take care of my multiplication of exponents before I do anything else. So that's going to be the x squared, and then the exponent of 3, and then the y, and then with the exponent of 3. And I'm going to just go straight to the multiplying here. So 2 times 3 is 6, and then 1 times 3 is 3. So that gives us x to the 6th over y to the 3rd. And then I've got this 5x squared y over 1. So when we're multiplying fractions, and we just multiply the tops together and we multiply the bottoms together. So I'm going to do that. On the top, we always put our regular number part in the front, so that's a 5. And then we'd have our x to the 6th and the x squared. And then we have our y. And in the denominator, we just have y to the 3rd, because multiplying by 1 doesn't really do anything. So in the numerator, I want to simplify the x to the 6th x squared. And I guess since I'm moving to the right, I'll just keep doing that. So the 6 plus 2, that's 8. So we get x to the 8 y over y cubed. Now, we're not done if we still have a variable that matches on the top and the bottom. So I've got a y on top and a y cubed in the denominator. So I need to simplify those further by using the rule where you subtract the exponent on the top from the exponent on the bottom. The y on the top, we can give it an exponent of 1. So it'd be 1 minus 3 when we simplify that. So we have our 5. We have x to the 8, and then 1 minus 3. And I'm going to still write that because usually that subtraction is where people start messing up. They usually don't mess up the multiplication, but it's a subtraction part that they do. So when you simplify this, we get 5x to the 8th, and then 1 minus 3 is negative 2. So that gives me y to the negative 2. And I need to take that negative 2 and rewrite it so it has a positive exponent. So my 5 and my x to the 8 stay on top. And then that y is going to become y to a positive 2, but now it's in the denominator. So we've got several steps going on here. And we're essentially following the order of operations when it comes to those exponents. I had to multiply the exponents before I did addition of exponents, before I did subtraction of exponents. And then the last step, you are flipping any negative exponents so they have positive exponents. And I think I've got time for one more. Let's do -2 x to the 6th, y to the -5, then 3 x to the -2, y to the 4th, and then that whole thing is in parentheses with an exponent of -3. So a lot going on here. When I do a problem like this, if I can simplify inside the parentheses, I will do that first before I do the exponent on the outside. And that's part of the order of operations, where you do parentheses stuff inside there before you do your exponent. So it's the same thing even with exponential expressions. So I want to simplify my x parts and my y parts before I deal with that outside exponent. And we'll do that by subtracting those exponents since they're in a fraction. So I'm not doing anything to the -2/3. So that's just going to be a fraction. And then on the x, I'm doing 6 minus -2. So we're subtracting a negative exponent. And then y, we have -5 minus 4. And then I have that -3 on the outside. So I've still got my -2/3. So this is why I usually write my subtraction, because when you subtract a negative, it's really easy to make a mistake. 6 minus -2 is the same as 6 plus 2. So we're going to get 8 on the x. And then -5 minus 4 is -9. And then that whole thing is to the -3 exponent. So once I simplify inside, order of operations say exponent, so that's going to be where we're going to distribute our exponent. So the -2/3 is going to get that exponent, the 8, x to the 8 is going to get the exponent, y to the -9 is going to get the exponent. And I'm making sure my -2/3 is going, it's in parentheses, so I have that -3. And then I've got x to the 8 in parentheses with the -3 exponent. And then y to the -9 to that -3 exponent. So we deal with the number part differently than the variable part. So the number part, the -2/3 to the negative exponent, we want to make a positive exponent, and you take the reciprocal. So if you have a fraction, you're just taking the reciprocal of the fraction. It still stays negative, so now it's going to be 3/2, and then we get the exponent of 3. So that works differently than if you have a whole number there where it becomes a fraction, or vice versa. So it just flip-flops that fraction to get that exponent to be positive. Now on our variables, you multiply those exponents. So 8 times -3 is -24. And then on the y, -9 times -3 is a +27. So anything with this negative exponent we want to simplify, but we also want to simplify our -3/2 to the 3rd power. So I guess I'll just go underneath it. So a negative to an odd exponent, so negative to an exponent of 3 is going to stay negative, so I can put that negative sign in there. And then you're just cubing the numbers. So 3 cubed is, I believe, 27. So I'm going to get 27 on top, and then 2 cubed is 8. So -3/2, that whole thing cubed is going to give me -27/8. Now we like to have these all in single fractions, so I'm going to take the y to the 27, which has a positive exponent, so I'm not doing anything with it. That's going to join the 27 on top. Then our x to the -24, we want to have a positive exponent, so that flips. And now it's going to be in the denominator along with the 8, so that's going to be x to the 24. And so we get a -27y to the 27 over 8x to the 24. And we can't reduce anything with the numbers. We have different variables. We don't have any repeated variables or anything there, so that's as far as you can go. So the key when you're simplifying these things is to go slowly to make sure you don't miss anything. Be very careful about what you write. You know, it's better to show more steps than not enough. And you're still following the order of operations. Simplify inside parentheses first, then apply your exponents, which means you're multiplying your exponents through parentheses and that sort of thing. Then do your multiplication and division where you're adding or subtracting those exponents. And then you're going to be doing any flip-flops if you have negative exponents remaining. So you're still following the order of operations. It's just now we're dealing with exponents instead of just regular numbers. So it's just slightly different, but the order is still the same.